Hello everyone, hope you're doing well. My name is Tawfiq Umar Rahman, math teacher. In this video, I will explain Chapter 3, Lesson 3, Part A, Continuous Function. Please do not forget to share it with your friends and subscribe the page to get new videos. And press the like button and write your question if you have in a comment, or send it to the email of the Facebook Mathematics for All. And now we are starting our lesson, Continuous Function. What is the meaning of the continuous function? The function is continuous if you can draw its graph without lifting the pencil from the paper. Here, if you draw any graph and you didn't lift your hand like this function is continuous. Or like this function is continuous. Or like this, and this function is continuous. Or like this, and this function is continuous. That means if you not lifted your hand from the paper, this function is continuous. But if you lifted your hand anywhere in this function will be not continuous in that point, like this. As you can see, we lifted our hand and started again. The function is not continuous here, but continuous in another place. Or you have a jumping from the function like this, then jumping here and start here. This function is not continuous in this point, in this place. That is the meaning of the continuity. Look carefully at these cases below. The first one, as you can see here, that we have a holy point here. That means the function is not defined in this point x equal to c. Why? Because the function is not defined here. The function fx is discontinuous because f of c is not defined. F of c is not defined, and there is a holy point. In the second case, as you can see here, we have a jumping. When we drew the function from here to here like this, then we are jumping here and continuing here. But there is a jumping here. Because the function is two parts, because of that, the left limit, if here, is different with the right limit, which is here. Therefore, limit is not exist. Because of that, the function is discontinuous. The third case is, as you can see, you have here a holy point which gives us a limit, and the full point which is give us a value of function. Because a limit is not equal the value of function, therefore this function is discontinuous. If limit is not equal the value of function, because there is a wholly point and jumping. And now, from what we take before, we can say that the function discontinuous at point x equal to c if satisfy one of these following. First one, if the function is not defined at x equal to c, or if c is not defined, then the function is discontinuous. The second one, limit is not exist when h approach to c. This function is not continuous. The third one, the function is defined and limit is exist but not equal. Therefore the function is discontinuous. And some of this continuous is removable and some of them is not removable. If the function is not defined and limit was exist, therefore in that case the discontinuous we can remove it. That means in this case when function is not defined and a limit is exists, we can remove this discontinuous by defining a new function like gx, writing f of x here when x is not equal to c, and limit down when x approach to c when x equal to c. In that case, g of c is equal limit when x approach to c for fx. That means g is continuous at x equal to c. Defining continuity. A function f is continuous at a point x equal to c if the following three conditions are satisfied. Here you can see that the function is defined. The function is defined when x approach to c and limit is exist, and the function and the limit is the same point, therefore limit when x approach to c for fx is equal f of c. The first one, the function is defined at x equal to c, that means f of c is defined. The second one, the limit when x approach to c for fx is exist. The third one, when limit and the function or the value of the function are equal. Let us take a first example. Discuss the continuity of each of the following function and determine the point of discontinuity if it is exist. A, fx equal 1 over x. As we know that the domain of this function is all real number except 0. That means f of 0 is not defined. That means f of 0 is not defined. Therefore, this function is discontinuous when x equal to 0, and it is broken when at x equal to 0. Because we cannot find the limit here when x approach to 0, therefore this discontinuity is not removable. But this function is continuous at all real number except 0. B, fx is equal x squared minus 1 over x minus 1. As you can see that the domain of this function is all real number except 1. Therefore, f of 1 is not defined. That means this function is discontinuous. If you replace it 1 in the function, it becomes 0 over 0. That mean is undetermined. Therefore, maybe limit is exist. So we try to find the limit. Limit when x approach to 1 for x squared minus 1 over x minus 1 is undetermined. Then we factoring the numerator. Limit is equal to approach to 1, x minus 1, x plus 1, x minus 1, cancelling x minus 1 with x minus 1, remain limit when x approach to 1 for x plus 1, replacing 1, then 1 plus 1 is 2. That means the limit is exist. Because the limit is exist and the function is not defined in that point, discontinuous is removable. There, to remove this discontinuity, we are defining a new function gx. Write the function which is x squared minus 1 over x minus 1 here, and say here x is not equal to 1 because it is not continuous at x equal to 1. And then the limit is 2, write limit here and write here x equal to 1. Gx is continuous for all real number. C, fx equal x plus 1 when x less than or equal to 0, or equal x squared plus 1 when x bigger than 0. When x is less than 0 and x bigger than 0, the function is continuous because they are a polynomial function. And when f is 0, when x is 0, and when x is 0, then f0 is 1. And the right limit is 1, and the left limit is 1, then the limit is 1. Because the limit is 1 and the function is 1 and they are equal, therefore this function is continuous at x equal to 0. Then it is continuous. Then it is continuous at all real number. Part D. Fx equal sine x. As we know that the domain of the sine is all real numbers, therefore this function is continuous at all real number. But if we want to prove that, take any number. Say let x be any number. Let b x equal to c, any number. Then f of c is sine of c, and limit when x approach to c is sine of c. Sine of c is equal sine of c. Therefore, the limit is equal the function, and function is continuous at all real number. Check it out. Discuss continuity of each of the following function. A, fx equal 1 over x minus 1. As we know that the domain of this function are real numbers except 1, therefore f of 1 is not defined, then function fx is discontinuous at x equal to 1, and it is broken at x equal to 1. Since limit of x approach to 1 for fx not exist because we have it unbounded value, that means is in the left decreasing without bounded, and at the left increasing without bounded, therefore the limit is not exist. Because the limit is not exist, this discontinuity, we can not remove it. That means this continuity is not removable. Fx equal x cubed plus 1 when x less than or equal to 0 minus x plus 1 when x is bigger than 0. And now to discuss the discontinuity, as you know that when x is less than 0 or bigger than 0, that this function is continuous because they are an polynomial function. Remain only at 0. First of all, find the f of 0. F of 0, we can replace 0 here because we have equality here. Therefore, 0 cubed plus 1 is 1. And now we are trying to find the limit. Limit when x approach to the 0. First of all, replace 0 here and replace 0 here. As we replace 0 here is 1 and replace 0 here is 1, 2. That means the right limit and the left limit are equal. The limit when x approach to 0 from the left, that means 0 cubed plus 1, which equal 1. And the limit when approach x to the 0 from left, that means is minus 0 plus 1, which is 1. Because 1 is equal 1, therefore the limit is 1. Because limit is 1 and f of 0 is 1, that means their value is equal. Then the function is continuous at x equal to 1. That means that the function is continuous when x is equal to 0, and therefore the function is continuous at all real numbers. Fx equal x cubed plus 1 over x plus 1. Because the domain of this function is all real number except minus 1. That means f of minus 1 is not defined. Therefore, this function is not continuous at x equal to minus 1, and it is broken at that point. And now, to know that this continuity is removable or not, we must find the limit. Limit when x approach to minus 1, x cubed plus 1 over x plus 1. Factoring x cubed plus 1 is become x plus 1, x square minus x plus 1 over x plus 1. And now cancelling x plus 1 with x plus 1, remain limit when x approach to minus 1 for x square minus x plus 1. And now replace minus 1, it become 1 minus minus 1 plus 1, that means is 3. Because the limit is exist, it is 3. Therefore, this discontinuity is removable. And to remove that discontinuity, we must define a new function. Let be gx. Write first of all the function x cubed plus 1 over x plus 1 when x is not equal minus 1. After that, write the limit, which is 3, when x is minus 1. That means gx is continuous at x equal minus 1 at all real number. D, fx is equal cosine x. As you know that the domain of the cosine is all real number, therefore this function is continuous at all real number. But to solve or to prove that, we take any number like c from the real number, find f of c is cosine c, and find limit when x approach to c, which is cosine c, because cosine c is cosine c. Therefore, the function is continuous at all real number. Discuss the continuity of this function fx equal x squared minus 3x plus 2 over x minus 1. As you can see in the graph, if was the graph be given, you can see you have here a wholly point. Therefore, at that point this function is not continuous. Because you have an wholly point, therefore this discontinuity is removable. And now, if the graph is not given, we can see that the domain of this function or real number except 1. That means f of 1 is not defined. Therefore, this function is discontinuous at x equal to 1. And it is broken when x is equal 1. To know that this discontinuity is removable or not, we must try to find the limit when x approaches to 1. For x squared minus 3x plus 2 over x minus 1, factoring x squared minus 3 plus x squared minus 3x plus 2 by opening two bracket, x plus time minus is minus time plus is minus, then 2 is 1 2. Therefore, cancelling minus 1 with x minus 1 with x minus 1, and then the limit is equal 1 minus 2 is minus 1. Because the limit is exists, then this discontinuity is removable. To remove this, we must define a new function. Let be f of x equal x squared minus 3x plus 2 over x minus 1 here, and then x not equal 1 and minus 1, write a limit here when x is equal to 1. Then the function fx is continuous at x equal 1 and all real number. Again, as you can see, we have here an wholly point. Therefore, this function is not continuous at x equal minus 2. Because we have an wholly point, then we can remove this discontinuity. And now, as you can see that the domain of this function is all real number except minus 2, and f of minus 2 is undefined, and the function fx is discontinuous at x equal minus 2, and fx is broken at x equal minus 2. And now we try to find the limit to remove this discontinuity. Limit when x approach to minus 2, x squared minus x squared plus x minus 2 over x plus 2. By factoring this, limit when x approach to minus 2, x plus 2, x minus 1 over x plus 2. Cancelling x plus 2 with x plus 2. That means the limit is equal to minus 3. Because the limit is exist, therefore this discontinuity is removable. And to remove this discontinuity, we must define a new function. Let be fx equal x, write the function x squared plus x minus 2 over x plus 2 when x is not equal minus 2, and write minus 3, which is a limit, and x equal to minus 2, As you can see, this function is continuous. Another kind of question which is important is coming from exam. Which function has a removable discontinuity? A removable discontinuity. To know that which one is a removable continuous, we must vectorize all the numerator. Here, x minus 3, x plus 2 over x minus 6. Here, x plus 1, x plus 3 over x plus 1. Cancelling x plus 1 with x plus 1 is become x plus 3. X minus 6, x minus 1 over x plus 6 is not cancelling. There isn't any cancel. X minus 4 and x plus 2 and x minus 2. As we can see, this, the function of a and c and d are not removable because we cannot cancel or anything here. It's not removable, not removable, not removable. But this one is become a polynomial function. Therefore, this limit is exist and this is a removable discontinuous. To remove this discontinuity, we must define a new function fx equal, write the given function which is x squared plus 4x plus 3 over x plus 1, and then write x not equal minus 1, and then take a limit which is 2 here, write it here, and x equal to minus 1. That means B has a removable discontinuity. Example, which one of the given function is continuous for all real number? The domain of this function is minus 3 to the positive infinity. And this function is discontinuous at all number when x is less than minus 3, because f of minus 3 is not defined and discontinuous at x less than or equal minus 3, because at minus 4, minus 5, minus 6, this function is not continuous. The second one, B, its domain is all real number. That means this function is continuous at all real number. The third one, domain is from minus infinity to 3. That means f of 3 is not defined and it is discontinuous when x is bigger or equal 3. The last one, domain of this function is from 0 to the positive infinity. F of 0 not defined, therefore discontinuous at x equal less than or equal to 0. That means the B is a right answer. What is the value of a so that the function fx is equal to x minus 3 when x is bigger than 3 at x when x is less than or equal to 3 has no point of discontinuity? We have two kinds of these equations. One of them, if the function is contained bigger or less, and the second one is equal or not equal. In this case, when we have bigger or less, greater or less, because we have no point of discontinuity, that means that this function is continuous. Fx is continuous. Because the function is continuous, that means the limit is exist. Because the limit is exist, therefore the right limit is equal the left limit. And now, to find the right limit, replace 3 in 2x minus 3, and to find the left limit, replace 3 in ax. That means 2 times 3 minus 3 is equal 3 times a. 2 times 3 is 6. 6 minus 3 is 3. Therefore, 3 is equal 3a. Dividing by 3, then a is equal 1. That means C is a correct answer. And at the second kind, what is the value of a so that the function fx equal x cubed minus 27 over x minus 3 when x is not equal 3, ax when x is equal 3, has no point of discontinuity. Because we have an inequality, we can use, because the has no point of discontinuity, that means the function is continuous. And in this case, we have, because the function is continuous, that means the f of fx is defined and the limit is exist and their value is equal. We can use the third condition, which is limit x approach to 0 to 3, fx equal f of 3. Every time you see the inequality, you use this one. And then limit when x approach to 3, we are factoring the numerator, x minus 3, x squared plus 3x plus 3, 9 over x minus 3. And now cancelling x minus 3 with x minus 3, there limit when x approach to 3 for x squared plus 3x plus 9, which equal 3a, and replacing 3 cubed squared plus 3 times 3 plus 9, 9 plus 9 plus 9 is 27, dividing by 3, therefore a is equal to 9. That means a is a correct answer. In which interval the function fx equal 1 over square root of x minus 2 has a point of discontinuity. To find the point of discontinuity, first of all, we must find the domain of this function. To find the domain of this function, make the denominator equal to 0. And to solve this equation, we must first of all take minus 2 from left to right. It becomes square root of x is equal minus 2. Sorry, plus 2. And now squaring both sides, then x is equal 4. That means the domain of this function, all real number bigger than 0 or equal to 0 except 4. Domain is from 0 to the positive infinity except 4. That means the f of 4 is not defined. Then f is discontinuous at x equal to 4. We can see here we haven't 4. That means in this interval from 0 to 1, the function is continuous. From the second one, from 2 to 3, the function is continuous. From 3 to the 4, because here is an open at x equal to 4, therefore 4 is not contained in this interval. That means the function is here is continuous. But here the 4 is in the interval, therefore this is a correct answer. And if we draw the graph of the function is like this, as you can see, the function is not continuous at x equal to 4. Here we came to the end of the video. Please share it with your friends so that everyone gets benefit. Please write your comment and subscribe to the page to encourage us. Also, please like and ring the bell. Thank you for watching. Goodbye.